Hey everybody, today we're going to get started with Unit 6, Polynomials. We'll get started with Section 6.1, which is mostly terminology. There's a bunch of vocabulary that we need for this section, and that's what most of this section is going to be on. Here we go, Intro to Polynomials. The first thing we need to go over is variables. So variables is something that we've seen before. We dealt with it in algebra. We usually saw it in the form of x, and it would represent some unknown quantity. It would hold some number, some value that we didn't know what it was, but we still need to be able to do stuff to it. Now, if we have this is called our variable. So let's go ahead and label that. So this is our variable. And we might have more than one of these. We might have double the amount. We might have triple the amount. So we would show that by putting a number in front. Instead of x, we now have 3x. There's 3 of these guys. And this number here, the number in front, this is called our coefficient. And lastly, if we took this variable and we multiply it by itself, we saw this when we were working with our exponent laws. Okay, x times x again would give you x cubed, or x times x would give you x squared. And that's another piece of this here. We may have an exponent on our variable. So I'll put an exponent right there. Now let's go ahead and label that as well. So this is called our exponent. Okay. We have 3x squared. This is essentially just the number 3 multiplied by x again. We have a product of all these pieces, and together they form what is called a term. So a term is defined as an expression formed by the product of numbers and or variables. Let's take a look at some other examples of terms. 5x cubed is a term. It's made up of 5 times x again times another x. So that's x cubed, so 5x cubed, that's a term. We could have negative 2x squared. That's a single term. Okay, all these pieces are joined together by multiplication, and they form a term. We could have just a variable. Single x, 1x, that's a term. You could even have different variables, like xy. This is x times y. That's a product of variables. That's a term. Okay. Now, it's when we stitch these terms together using addition, that's when we have these polynomials. So polynomials are expressions formed by connecting terms with addition. So you have these terms. They could be positive, they could be negative, and when we add them together, that's when we have polynomials. I'll give you an example. Here's 3x. That's a term. Then we have 5. That's a term. And when we put them together using addition, so 3x plus 5, that's an example of a polynomial. It's a bunch of terms stitched together with addition. Let's take a look at one that has a negative term. So we have positive 2x squared. We have negative 4x. And when we add them together, that forms 2x squared minus 4x. That's a polynomial. You can have more than 2 terms. You can have something like this, 3x squared minus 7x plus 5. Okay. So we have a positive 3x squared, that's one term. We have a negative 7x, That's another term. And we have positive 5. That's yet another term. Stitch them all together. 3x squared minus 7x plus 5. That's a polynomial. Okay. One last thing before we move on to special polynomials is a constant. So a constant is a term with only a number. In other words, there's no variable. And this is an example of one right here. Okay. So we got this 3x squared term, we have this negative 7x term, and that 5, that positive 5, is what's called our constant term. So any term that doesn't have any variables at all, if it's just a number, is called a constant term. Let's get into some more specific types of polynomials. So there are some category of polynomials. The first one is a monomial. Now when you think monomial, you think of the prefix mono, right? Like monorail, right? What does that mean? One rail. So this is a polynomial that just has one term. And so these single term polynomials, such as 3x. Okay? Single term, it's a polynomial, and it only has one term. Y squared, another single term polynomial. 15, single term, constant, right, polynomial. That's a monomial. We also have binomial. Okay, so think of the prefix bi, right? Biannual, bicycle. Okay, it means two. So a binomial is a polynomial with two terms. So any polynomial that's made up of exactly two terms can be categorized as a binomial. So something like x plus 5. That's a binomial. W squared minus 7. Okay? We got w squared term, we got a negative 7 term. That's a binomial. All right. And then the last category is a trinomial. So tri. What do you think this one is? Yeah, 3 terms. So a polynomial with 3 terms is called a trinomial. So an example of that would be x squared. There's one term. 5x. There's another term. Negative 1. There's another term, right? These are all stitched together to form a polynomial, but more specifically, this is called a trinomial because it has exactly 3 terms. Let's take a look at another one. Let's take a look at one with a nice little mixture of variables. So let's say 7a squared minus 4ab plus 3b squared. Looks complicated because of the different variables, but again, 3 terms stitched together by addition. This is a polynomial, but more specifically, it's a trinomial because of the 3 terms. All right, next we're going to take a look at the concept of degree. You'll notice that some of these variables have exponents on them. Okay, and that exponent represents how many times that variable was multiplied by itself. The degree counts basically how many layers of variables you have multiplied by one another. So by definition, the degree is the sum of the exponents on the variable of a single term. Okay, so we're looking at the degree of a single term and take a look at how many variables were stacked up on one another, and that's the degree. This will become a little more clear when I give you an example. Let's take a look at 3x squared. There's only one variable here, it's x, and there's only one exponent on it, the 2. So looking at this exponent here, okay, the degree is 2. Let's do another one. 5y to the power of 4. Okay. This one here, this variable y has a exponent of 4. And so the degree of this term is 4. Okay. So these are pretty straightforward. When you have only one variable to worry about, you only really have to take a look at that exponent on the variable, and then you're done. This is 2x. Now, it doesn't show an exponent, but there is one there. They just don't bother writing it. It's a 1. Okay. All right. Let's take a look at terms that have multiple variables. Let's take a look at something like this. This is 3x squared y cubed. Okay, so we've got an x variable and we have a y variable. The degree is measuring how complicated, how stacked up is this term. Okay, so we've got an x. It's x squared, so we got another x. Then we have y cubed, so that means there's a y and a y and another y. So how many layers do we have here? Well, we've got the 2 here, and we've got the 3 here. So how many variables do we have stacked up on top of each other? We have 5. And we can just add these exponents together. And we can say that the degree is 5. Right? That's how complicated this one term is. There's 5 variables stacked up on top of one another. Okay, moving on. Now that we can find the degree of a single term, let's now take a look at how we find the degree of a polynomial. And so the degree of a polynomial is really just the degree of the highest degree term, right? You take a look at all the terms in the polynomial, you find the one with the highest degree, and that's the degree of your polynomial. So really the question is, if you're trying to find the degree of a polynomial, you're really asking, hey, what's the most complicated term you have in that polynomial? I'll give you an example. We have 7x squared minus 2x. So that's my polynomial. Let's take a look at this first term, this 7x squared. It has a degree of 2. And this term, this negative 2x, this has a degree of 1. So, the degree of this entire polynomial is the highest of those 2. So 2. Let's do one last example. We had 7x squared plus 4x cubed minus 1. So looking at this, let's take a look at this term here. So the degree of this term here is 2. Let's take a look at the second term, and the degree of this one, see there, it's 3. And then this one here, this is a constant, okay? There is no variable, so degree is 0. So of these three terms, the highest degree is 3. Therefore, the degree of the polynomial is 3. And there you go. That's all we have for today. That's 6.1. Tune in next time, and we'll cover the next section. Bye.